The only thing I ever want to hear about a comet that's approximately the size of Manhattan is that it won't be coming anywhere close to Earth. And yes, I get it. The term close is relative, especially in space. But this rock in question is headed our way. It's called 3I Atlas, and it is set to get as close as 167 million miles away from Earth by December 19th. That is 6 weeks from tonight. So what's the big deal exactly? The big deal is that not everybody's convinced it's a comet. And now you've got my attention. A Harvard astrophysicist named Avi Loeb has pored over the latest images and was struck by the, quote, non-gravitational acceleration of 3I Atlas. It moved faster than gravity could explain. It also looked oddly blue, when in past observations it was red and then green. That Harvard professor was kind enough to give up a Friday night to join me here live. And boy, do I have questions, Professor. First of all, should we be prepping?
We should monitor it. Thanks for having me. That's the way science is done. We shouldn't assume we know the answer about its nature in advance. It's a blind date of interstellar proportions. And my advice on blind dates is watch the other side before you say anything.
Yeah, well, that's a good point. Let's talk about 3I Atlas and how it is different from all the other rocks and comets that have, come dancing into our solar system. Why is this one standing out, other than the blue light that I mentioned before?
Oh, first of all, it's very big. It's the size of a city, 5 kilometers in diameter, 1,000,000 times more massive than the first interstellar object that we discovered 8 years ago. This is just the third, and it's so massive. There might not be enough material in interstellar space to deliver such a big object to our neighborhood over the past decade. Another thing is that it moves in the plane of the planets around the sun, which is very surprising, a chance of 1 in 500. It shed some nickel without much iron, which is very surprising because the only place we find nickel without iron is in industrial production of nickel alloys. And most recently, as you pointed out, it actually showed some non-gravitational acceleration. There was some propulsion that moved it away from its original trajectory. And I would have expected that it would lose 10 to 20% of its mass as a result of the recoil from that mass loss. And we don't see any cometary tail around it in recent days after it passed closest to the sun on October 29th. So all of these are anomalies. There are 10 of them. I didn't list all of them. And that's what makes me ask the question, is this technological in origin? Because when you have a visitor to your backyard, you better know its nature. Otherwise, it might show up at your front door. And we can't afford to just adopt the most likely interpretation, which is that it's a natural object.